Welcome to Daily Papers.
If you've ever used an AI coding assistant like GitHub Copilot or ChatGPT to help you write code, you've probably wondered, how good is this thing really? Is it a genius programmer or is it just good at guessing?
Well, today we're looking at a paper that tries to answer that exact question. It's about creating a new, tougher, and much more realistic obstacle course for AI coders, testing them not just in one programming language, but in a dozen at once.
The AI models behind these tools, called large language models or LLMs, are getting scarily good at writing computer code. But to know just how good they are, scientists need to test them with something called a benchmark.
A benchmark is basically a standardized test for AIs. You give the model a set of coding problems and see how many it can solve correctly. It's like a final exam for our digital students.
But there's a huge catch with most of these exams. They're almost all written in one language, Python. And that's a problem because the real world of software is a wild jungle of different languages.
Exactly. It's a digital Tower of Babel out there. You have JavaScript and TypeScript building websites, Java and C# powering big corporate systems, C++ for high-performance video games, and Rust for super safe, efficient software. Relying only on Python to test an AI is like judging an Olympic athlete based only on how fast they run the 100-meter dash.
You have no idea if they can swim or do the high jump or lift weights. An AI might be a Python genius, but a complete novice when you ask it to write something in a different language. We just haven't had a good way to test that versatility.
Until now, this paper, titled Multi-LCB, Extending LiveCodeBench to Multiple Programming Languages, builds on a really clever existing benchmark to create a true multilingual test for AI.
So first, let's talk about the foundation they built on, which is called LiveCodeBench, or LCB for short. LCB is clever because it's designed to be contamination aware.
Okay, contamination sounds bad. What does that mean in the world of AI?
Contamination is a huge problem. Think of it like a student getting a copy of the exam questions and answers before the test. These AI models have been trained on basically the entire internet, so it's very likely they've already seen the problems in older benchmarks and have just memorized the answers.
So their high score might not reflect true problem-solving skills, just a good memory.
Precisely. LiveCodeBench gets around this by constantly adding brand new problems from very recent online programming competitions, problems that are just days or weeks old. It's so new there's almost no chance the AI has seen it before. It's a fresh, fair test.
Aha! But the original LiveCodeBench was still just for Python, so this is where the new paper comes in. They created Multi-LCB. The multi stands for multiple languages.
Yep, they took all those fresh, contamination-free problems from LCB and built a system that could ask an AI to solve the exact same problem in 12 different languages. We're talking Python, C++, Java, JavaScript, Rust, Go, C#, and more.
That is a huge deal. It means for the first time, researchers can make a direct apples-to-apples comparison. They can take the same problem, give it to the same AI, and say, solve this in Python, then now solve it in Java, and now do it in Rust.
So they took 24 of the world's leading publicly available coding AIs and put them through this new multilingual gauntlet. The results were very revealing.
Let's hear them. What was the first big discovery?
First and most importantly, being good at Python does not mean you're good at everything else. The researchers found substantial and practically meaningful performance gaps across languages. Some models that were top of the class in Python absolutely stumbled when asked to code in a different language.
So it's not a good proxy for overall coding ability. What did the researchers call this phenomenon?
They called it Python overfitting. The term overfitting means the model has trained so much on one specific type of data, in this case Python code, that it performs poorly on anything else. It's become a specialist, not the general-purpose coding wizard we might imagine.
It's like our 100-meter dash runner. They are incredible on the track, but the moment you put them in a swimming pool, they sink.
Exactly. They also found that the type of language made a huge difference. Models tended to struggle a lot with what are called statically typed languages like Java, C++, and Rust.
Can you break that down for us? What does statically typed mean?
Think of it like this. A dynamically typed language like Python is very flexible. It's like telling a friend, hey, go get me that thing. They'll figure it out from context. A statically typed language like Java is much stricter. It's like saying, please retrieve the blue ceramic coffee mug with the chip on the rim from the second shelf of the kitchen cabinet. You have to be incredibly specific.
And the AIs tripped over all those specific rules.
A lot. They would make more syntax errors, forget to import necessary libraries, or get the data types wrong. The strictness of these languages really exposed the model's weaknesses.
So what's the big takeaway from all this? Why should the average person care about a new AI benchmark?
It means we need to be much more critical when we hear claims about an AI's coding abilities. If a company announces their new model is the best coder in the world, the first question we should ask is, the best at which language?
This paper gives the whole field a much more honest and realistic report card for these AIs. It's pushing developers to build models that are truly versatile, that can help a programmer whether they're building a website in JavaScript or a game in C++.
Ultimately, it's about building better, more reliable, and genuinely useful AI tools that can work across the entire landscape of modern software, not just in one corner of it.
A tougher exam to make sure our AI students are actually learning the material. That's all the time we have for today on Daily Papers.
Join us next time for another deep dive into a fascinating piece of research.